So let's do an actual problem. If you want to follow along with your textbook, this example comes straight out of the book on page 325. So, suppose a social psychologist is studying the influence of knowledge of previous criminal record on juries' perception of the guilt or innocence of defendants. The researcher recruits 15 volunteers who have been selected for jury duty but have not yet served at a trial. The researcher shows them a DVD of a 4-hour trial in which a woman is accused of passing bad checks. Before viewing the video, however, all of the research participants are given a background sheet with age, marital status, education, and other information about the accused woman. The sheet is the same for all 15 participants with one difference. That is going to be your independent variable. For 5 of the participants, the last section of the sheet says that the woman has been convicted several times before of passing bad checks. We will call those participants the criminal record group. For 5 other participants, the last section of the sheet says the woman has a completely clean criminal record. We'll call this the clean record group. For the remaining 5 participants, the sheet does not mention anything about criminal record one way or the other. We'll call this our no information group. The no information group is used similar to a control group. The participants are randomly assigned to groups. After viewing the video of the trial, all 15 participants make a rating on a 10-point scale, which runs from completely sure she's innocent, that it would be a 1, to completely sure she is guilty, which would be a 10. The result of this fictional study is what we're about to walk through. And you'll notice the different means. So, our criminal record group, our 5 participants had scores of 10, 7, 5, 10, and 8. Remember, 1 is believed that she is innocent, 10 believes that she is guilty. Our clean record group has ratings of 5, 1, 3, 7, and 4. And finally, the group that had no information gave ratings of 4, 6, 9, 3, and 3. If you take the data and do what we've done all along to create the variance for each one of these, you will create a deviation from the mean for each participant's score using the mean of that group. For instance, in the criminal record group, if you sum the score, you will get 40 points. If you take the particular score and divide it by the total number of participants, which is 5, you'll get a mean of 8. If you then take your mean score and subtract it from each one of your participant scores, you get the deviation from the mean. Remember, the deviation score should always add up to 0. If it adds up to 0.1 or something along those lines, that's simply due to rounding. Once you get your deviation scores, you square them and get your square deviation for the mean. Our square deviation for the mean for group 1 is 18. Our square deviation for the mean for group 2, the clean record group, is 20. And our square deviation mean for no information group is 26. We now use our square deviation scores to create our variance for each group. So our variance for group 1, the criminal record, would be 18 divided by the total number of degrees of freedom, which would be 4 in this case, because we have 1, 2, 3, 4, 5 scores. So the sums of squares here, or the variance, is going to be equal to the square deviation for the mean divided by the degrees of freedom. So Our variance for our criminal record group is 4.5. Our variance for our clean record group is 5.0. And our variance for our no information group is 6.5. So let's create our variance for within group. You'll also hear it called within group variance, and as I said, you'll also hear it called within group means of squares. So what we do is our variance scores, or our sums of squares scores that we calculated for each group, 4.5, 5.0, and 6.5, we are going to add them together, and we are going to divide them by the total number of groups we have. So we have 4.5 plus 5.0 plus 6.5 divided by 3 because we have 3 groups. That gives you 16 divided by 3, and it gives you a mean square within of 5.33. So we have the first half of our ratio. We now have to compute our between group variance. It's a little more complicated, but it's not impossible. So our formula for our between group variance is also used to compute a variance for a distribution of the means. We have to compute a variance for the distribution of the means because we have 3 different groups. We do not know their population variance, and so we have to estimate their population variance from our group variance. We are going to take that information and when we're going to use it to come up with our variance for between. So this symbol is the variance for the distribution of the mean, and it is an estimated variance for the distribution of the mean. So here's what we're going to do. We are going to take each mean score. We are going to subtract a grand mean from it. We're going to square them, and then we're going to divide them by the degrees of freedom for the between group. So let's start with our variance for our distribution of the mean. If you'll notice, our mean scores here are as follows again: 8, 4, and 5. Those are the same means that we had previously from here: 8, 4, and 5. We are going to take those means. We are going to sum them. We are going to get a sum of 17. We're going to divide them by the total number of scores we have, which is 3. And it is going to give us a grand mean of 5.67. We are now going to compute a deviation from the grand mean. It's the same type of deviation scores you've computed before. Instead of this time, you are subtracting each group mean, and you are going to take the grand mean from each group mean. So, our first group mean was 8. We are going to subtract 5.67, which is the grand mean, which gives us 2.33. We're going to subtract 5.67 from 4, which gives us a negative 1.67. And we're going to subtract 5.67 from 5, which is going to give us a negative 0.67. We're going to square each one of those to get our square deviation from the means. And then we're going to sum those to get 8.67 as our squared deviation from the grand mean. In other words, this number. Now, to complete this formula, we have to divide it by the degrees of freedom between. The formula for degrees of freedom between is simply the total number of groups minus 1. In other words, we have 3 groups minus 1 gives us a degrees of freedom between as 2. So now our variance, our estimated variance for the distribution of the means is our grand mean formula squared 5.67 divided by our degrees of freedom between, which is 2, gives us 4.34. Hang in there with me. We're almost done. To get the final part we need to get our estimated variance for the between groups, that is, we're going to estimate the variance of the population of the individual scores. We're going to do between group. We are now going to take our estimated variance for the distribution of mean that we calculated, our 4.34, and we are going to multiply it by the number of participants in each sample, total number. So we're going to take our 4.34. We had 5 participants in each group. We're going to multiply 4.34 times 5, and it's going to give us 21.70. Our final calculation is we take our variance for between and we take our variance for within, and we put them into a ratio. Our between goes on top, our within goes on bottom. So just think B top, W bottom. 21.70 divided by 5.33 gives us an F of 4.07. Now, as I said, there is an F table similar to the T and the Z table. If you will look in the very back of your book, and my F table starts on page 678, you will notice that there is a curve, and you'll also notice that it's skewed. You will notice in the first column it says denominator degrees of freedom. The second column says significance level. And then across the top it says number of degrees of freedom. So the way this works is that, remember, between on top, within on bottom. B on top, W on bottom. You calculate your degrees of freedom for between. We've already done that. It's the total number of groups minus 1. We had 3 groups. Minus 1 leaves us 2. Our degrees of freedom within is simply N minus 1 for each group. And then we add the 3 degrees of freedom together. So in our example, we had 5 participants in each group. 5 minus 1 for the first group is 4. 5 minus 1 for the second group is 4. 5 minus 1 for the third group is 4. 4 plus 4 plus 4 is 12. So our degrees of freedom between is 2, and our degrees of freedom within is 12. So if you would look, it says denominator and it says numerator. If you will look at our example here, between on the top is the 2, so we go here for numerator degrees of freedom, which is 2. Our degrees of freedom on bottom, denominator, is 12. And we are going to look at this at the 0.05 level. So you intersect 12 degrees of freedom for the denominator at the 0.05 level with 2 degrees of freedom at the numerator. And it comes up 3.89. Our answer was 4.07. So our F value exceeds the cutoff required for an F of 3.89. Therefore, we would reject the null hypothesis, and we cannot assume that the group means are equal if the null hypothesis is true.